For a lot of you, this is going to be your final exam. It is physics, paper 2, and you want to be getting a grade 9. You want to be getting the best grades possible so that you can leave this exam ready to enjoy your summer, knowing that you did as well as you possibly could. You went in there, you maximised all of the marks in every single one of the questions. So this particular paper is going to be testing you on forces, on waves, magnetism and electromagnetism, and space physics for triple science students. And we're going to be going through what some of the more common areas that are likely to come up on this paper are going to be, what examiners have been saying are common mistakes that students make so that you're not going to be making them, as well as just thinking more generally about ways in which you're going to be able to tackle every single one of the questions that comes up in this paper. You're not going to be leaving anything blank. Let's get into things. First of all, forces is going to take up the majority of this paper. That is the most heavily assessed topic across all of the past papers. They really like to test your understanding. And they do this in two different ways. They do wordy questions and they also do calculation questions. So for calculation style questions, this is where all of your equations come into their own. You need to be understanding what the equations are and in what context you use them. If you're not a massive fan of forces calculation questions, then the fundamental thing that I will recommend you to do is go on Isaac Physics and just try some of the questions this evening. Just focus in on those topic areas that you might be finding slightly harder. So for example, if you find momentum questions slightly harder, or you find stopping distances slightly harder, Isaac Physics is the best place. It doesn't give you the answer unless you get it correct, but 9 times out of 10, if you copy paste the question itself into Google, you will get the answer. Or you can ChatGPT it and see if the answer that ChatGPT gives you is correct, in which case you can follow the working. But it might not give you the correct answer, so I'm not going to say that is the fundamental thing that you should be doing. But 9 times out of 10, you're going to be able to find the answers online. I do just think Isaac Physics is a wonderful resource for this. But the area of forces that a lot of people will leave out of their revision is thinking about the sort of more wordy problems, thinking about particularly explaining safety features, so things such as airbags or crumple zones, which relate to momentum, as well as talking about the factors that affect stopping distances, whether that be the driver themselves or whether that be the conditions of the road. So it's these sorts of things where you'll get 4-mark questions that require detailed worded answers, that in order to get the marks, you might understand the scenario, but you have to be using very specific language. And this is why if you're not 100% confident on this, I would say today, go to Physics and Maths Tutor or go to Cognito, have a look at a question pack that is specifically about stopping distances, momentum, thinking about safety features, and just, even if you're not answering the questions themselves, which I would say probably do that, but even if you don't have the time for that, just look at the mark scheme and see exactly which words it wants you to use, because a lot of the time it wants you to use very specific phrasing, which if you do not use, you do not get the marks. Obviously in forces, we've also got terminal velocity. That is a big wordy question. They sometimes do 6 markers on terminal velocity. If that comes up, which it didn't last year, so it's disproportionately likely to come up this year, do know what those sort of 6 phases that will get you the marks are. Again, literally just go to the mark scheme and quite literally just memorize it. You can write it down on a little cheat sheet if you think that it's something that you're not going to remember and you're just going to be able to look over it right before you get into the exam, so that if you do get a terminal velocity question, you can basically regurgitate the 6 points that get you the 6 marks. And that is a very easy 6 marks for you to get. And obviously also in forces, you've got Hooke's law, you've got elasticity of springs, thinking about the required practical in that case as well. We'll come back to the required practicals, but it's just knowing when to use Hooke's law, for example, and talking about plastic deformation as well. Now for waves, know the electromagnetic spectrum, know the different sort of uses of the different types of radiation. In particular, thinking about like X-rays in medicine, being able to do these wordy problems, because waves is another one of those topics where students will know the equations, they'll know how to manipulate them and answer questions, but when you get these wordier questions, these things that ask you about uses of electromagnetic waves, or if you're in triple science, then sound waves, then they get a bit stumped because that's not the direct question and answer using equations that they have maybe revised for. So do just make sure that you are able to tackle these wordier questions, obviously not neglecting to know the equations, some of which are given to you, some of which are not, you need to memorize. Magnetism and electromagnetism, make sure you know Fleming's left-hand rule, right-hand rule as well. That's my left hand and that's my right hand. I'm doing excellently this morning, but make sure you're doing it with the right hand. That is a great starting place. But obviously knowing your force diagrams and being very, very specific that when you're drawing force diagrams, you draw at least 5 sort of force lines Because if you draw too few, then you actually cannot get all of the marks. The exam, like if you just draw 1 or 2, then the examiner is not able to give you full marks, because in the mark scheme it states there is a minimum number needed, that is normally 3 to 5, be on the safe side and just do 5 as that sort of baseline level to make sure that you're not losing marks that you should be getting because you understand that you're just not drawing enough force lines. Triple science is thinking about transformers, knowing your transformer calculations, using the F equals Bill equation, and generally having a bit more of an understanding of induced potential, so the generator effect, which is quite difficult at GCSE to wrap your head around, but the best thing that I would recommend for this is just finding videos that basically use a little diagram and animation to explain the process. Similar for transformers, that can be really useful, but also for non-triple science students, just having a look at animations to see how forces actually operate can be really, really useful in terms of when you're presented with a wordy question and you need to think about, okay, what are the forces acting in this scenario? Obviously, drawing a diagram is the best thing you can possibly do, but if you're familiar with all of the different forces that could be acting, it's going to be a lot easier for you to create that accurate diagram. And of course, for triple science students, space physics, thinking about orbit, the sort of speed and radius of these orbits, thinking about redshift as well, being able to explain how redshift is used as evidence for the expansion of the universe, as well as thinking about making sure that you can do those orbital motion calculations. These equations should be given to you, but make sure that you're very familiar with using them, particularly because this is a topic that most students have learned really quite close to exams, so you're not as familiar with it as you will be for other topic areas in this paper. So do make sure you give it some time. I know it's a small part of the specification, but it's always tested. So do just be careful on it. Now let's have a think about what examiners themselves have said in their examiners reports following the last couple of papers. The first thing that they say is required practical questions are answered really, really poorly. So thinking about required practical questions related to Hooke's law, less than 10% of students will get full marks in these sort of practical questions. And that is because generally when you're asked to explain the methodology behind the practical, people will leave things out. People won't talk about the independent-dependent variable. They won't explicitly state what equipment is needed, and they won't state why steps are being taken. For example, if it is to improve accuracy, reliability, make it more repeatable, you need to be including all of those 3 components when you are describing the method of a certain practical, and that also applies for the waves practical as well. Generally those are answered slightly better than the Hooke's law practical questions, but you never know which are going to come up. So you need to be familiar with the methods, why the different steps are being taken. Best thing I could advise for you if you're thinking, okay, I need a bit more practice on this, is 1, find question packs on Physics and Maths Tutor. They have specific practical based question packs. And 2, watch someone doing the practical. Go on YouTube, search up, GCSE physics, required practical, whatever number it is, demonstration, and there will be a demonstration, a teacher doing it, talking you through it. And just having watched it again can, 1, help you recall when you did it, but also 2, if you did it and you didn't do it amazingly, you and your partner perhaps didn't get the best results, then you're going to have a good set of results, seeing exactly how the experiment should be done in the way that the examiners want it to be done and want you to talk about it. The second thing is that on physics papers, examiners are trying to trick you. They will give you information in the question in a certain unit, and then your answer will have to be in a different unit, and you will have to do conversions. You might be, for example, really used to using meters in your waves calculation questions, but they give you all of the quantities in the question in centimeters or millimeters. And you need to remember that you've got to convert that, otherwise the equations that you know don't hold. And it's similar for other things. You need to be checking the units and making sure you're putting them into the appropriate units in order to use the equations and in order to get the answer in the specific units that they want that answer to be in. And this is why it is so essential that you show every single step of your working, because if you misuse the units, you're still going to be able to pick up on a lot of marks. You'll get marks both before making that mistake and after making that mistake, but obviously you won't get the final answer marks, nor will you get the marks for the step in which you use the incorrect units. But if you don't show all of your working out, then you're just not going to get the marks. So you need to be showing every single step. And I know I reiterate this, but it'll be the last time I reiterate this, because this is, for most people, the last GCSE paper. So do yourself a favour and make sure you are checking, you are writing down everything. Even if you're using a calculator for the majority of calculations, just write down exactly what you're doing. Now, explanation wordy questions are hard in physics, and a lot of people do not like them. And I didn't especially like them until I got to A-level, and I realised that actually there is a formula for answering these questions. What they want you to do is state your points, give a bit of an explanation, but always link it back to a physics principle. So if you're getting questions, there are things like on braking distance, on momentum, on electromagnetic forces that are wordy questions. You've got to be using really subject-specific terminology. It's that linking back to a physics principle that makes sure that you get the marks. So you should be using words elastically deformed. Is it a virtual image? Is it a real image? Are you talking about work done? Are you talking about kinetic energy, vectors, scalars? You need to be thinking about all of these keywords, and a really good way of making sure these keywords are really at the forefront of your brain is just looking literally for glossaries in the back of a textbook, or you can find them online, and just have a look at the keywords and make sure that you can define them. And from doing that, if you can sort of group them into subject-specific sort of keyword groups, then you're going to know that when a subject comes up, so for example, you've got a question on waves, you're going to have an idea of all of the keywords that are related to that topic area that you're then going to be able to pull out and think, okay, I need to put these keywords into my answer. Because even if sometimes you're not getting the explanations fully correct, having the keywords can still mean that you're picking up marks. Lastly, in almost every single paper, they will have an evaluate question, whether you're sort of evaluating data reliability or experimental methods. When you see the keyword evaluate in a physics paper, that is the same as if you're seeing the keyword evaluate in any other subject. You're still having to provide a conclusion, and the marks are still split between you weighing up whether it is good, weighing up whether it is bad, and providing that little bit of a conclusion. So make sure if you are seeing that keyword, you are using your actual evaluation to actually have a conclusion. And now that's not to say, some broad-based conclusion. It's as simple as, and therefore this experimental method is accurate or is reliable or is not, whatever it is, but linking to sort of what the question is asking you. It's not some elaborate conclusion, but it is a statement of conclusion being on one side of the fence or the other. And similarly, these are going to be 6 markers. The other type of 6 markers are the extended calculation or the graphical interpretation questions. You've got to get good at graphical interpretation. I noticed the day before, it is very hard to get good at graphical interpretation the day before your exam, but if it is something that you struggle with, there are specific graphical interpretation question packs on Physics and Maths Tutor that I would highly recommend you have a look at. Those are my tips for your Physics GCSE Paper 2. Good luck. For those of you for whom it's your last exam, I hope you enjoy the freedom of your summer, and for everyone else, you've only got a couple of papers left. So good luck with the rest of them. If you have any questions, let me know in the comments and I'll do my best to respond. See you in the next video.